Today I'm going to be talking about photosynthesis. Photosynthesis occurs in plants and specifically in the chloroplast. Within the chloroplast there are small disc-like structures that are called thylakoids, and a stack of these is called a grana. Over here is the thylakoid space, and out here is the stroma. As we see, it starts off with photosystem 2. Chlorophyll is within the photosystem. We have a carrier protein, photosystem 1, chlorophyll within it, carrier proteins, and then down here ATP synthase. So we're going to set up some water inside the thylakoid space. So starting off, light from sun or artificial sunlight comes into photosystem 2. Electrons become excited and start moving down the electron transport chain. As this happens, the electrons need to be replaced. So water bounces right here and breaks apart. This is called photolysis. As water molecules breaks apart, oxygen begins to build up, and oxygen combines when it's in its most isolated state, so it becomes O2. And now we have an abundance of protons or H plus molecules. So as the electrons move down the chain, H's from the outside come in, protons from the outside. This is a proton gradient. These protons are going to want to leave as soon as possible. The electrons are now losing energy and they come to photosystem 1. They are excited again and then move through a carrier protein where H's again come down into the thylakoid space. Electrons are moving down the chain, and NADP, an electron acceptor, is wanting to attach, and hydrogen attaches to NADP and creating NADPH. And ATP synthase right here, the H's, as I said before, are building up and move through the ATP synthase and combine with adenine, ADP, to create ATP. So through the electron transport chain, we have now created NADPH and ATP, both of which will be used in the dark reaction or the Calvin cycle, the second part of photosynthesis. So now I'm going to be talking about the Calvin cycle, which happens in the stroma. CO2 is taken from the air as well as previously assembled ATP and NADPH. Over here we have a line of 5 carbons. This is RUBP. Now CO2 from the air is going to give carbon to this molecule. Ribisco, an enzyme, is going to help weld them together, and this is carbon fixation. Now ATP and NADPH are using their energy and knocking off their proteins, their H pluses, to split these molecules in half. Now we have G3P. We're going to set aside and store a line of 3 of carbon. And then we're going to reassemble the RUBP. Carbon is going to then give more carbons to the strand, and then ATP, formed from the previous light reaction, is going to then come again and use its energy to split the molecules in half. We're going to store one more G3P, and we should have 6 carbons forming glucose. And this cycle keeps on going because you can just regenerate your RUBP again.